Alright, howdy y'all. It's the Diabolic Bee Tutor. And today we're going back to trigonometry. Unfortunately, we are going to hit one of the more annoying properties. It's going to be the sum to difference. Sum to product or difference to product. Or product to difference or product to sum or whatever you want to call these ones. Unfortunately, it's one of the worst sections. So, here we go. And right off the bat, instead of writing it out, I just have it copy pasted right here from the internet. And unfortunately, it is kind of low resolution. But the thing I want to talk about is, unfortunately, these are the things that we are going to be dealing with today. But it's not all terrible though, because it looks like a lot, but it's actually a little less than what's shown right here. So if you notice this one in particular, these two in particular, you have a sine something times cosine something else. Well, isn't that just the same thing as cosine something else times sine something? So for the most part, these two, they're just commutative property. You can multiply in any order you wish. So you can choose to multiply the sine first, or you can choose to multiply the cosine first. So thankfully, we don't really need the second one. So again, just a little bit of rearrangement, and then you should be good to go. And then these two, we can kind of condense them so that it's less to look at. Unfortunately, there are separate rules, but this one is positive, then it leads to the positive first, and then the minus second. And then, oh, actually no, we do need a separate one for this one. Yeah. Oh, you know what? No. Alright, so basically these two can be combined into one if you wish, so it just looks like less to memorize. So when this is a positive, then this is sine, and then this is sine first, then this is plus, and then this is plus. But if this is subtraction, then this one, in my opinion, should be like placed like right there. If this is minus, then it leads to minus. And then the second cosine one, the sign has been alternated. So this one is basically, if you can memorize the, what was it? This formula right here, remember this one? So if you have sine of, in parenthetical, a plus b, and then we do the expansion for this one, the sign keeps the same sign, and it changes into sine a cosine b, keeping the same sign, and then plus cosine a sine of b, right? So if this is plus, then this is plus. If it's minus, then this one is minus. And because basically this rule right here is derived from the cosine version of that one, well, for the most part, we can just kind of rearrange these sort of situations. So again, it's a little less to memorize. So if this is plus, then that is plus, and that would be minus. And then to summarize this one, or combine it into this one, so to speak, to make slightly less to memorize. So if this had been minus, if this is minus, then this one will be minus, and then this one will be plus. So marginally less to memorize, kind of. And then these ones, I think we have no choice but to memorize those, or at least have them handy to reference. And again, this one is, I don't know why this is written right here. We don't need this one right here. So these three should be enough, and then those three should be enough. And then those are the ones we're dealing with. And these ones can be derived from the cosine version. So if you have cosine of a plus b, we can expand it out using the first rule that we learned. This is probably the most important one. Then this is cosine, so we keep the cosines together. So cosine a times cosine b. And then we don't keep the same sign, so it'll be minus and then sine a sine b. So there we go. And if you have the cosine with the negative inside, And we're pretty much doing the exact same thing, except this one will be plus. Just copy paste. Alright, and then if you notice that we can take the equation number 1 and we can add it to equation number 2. So these two are two different types. So we have cosine of a plus b plus this one. Is equal to, and then something magical happens right here. Equal but opposite. Equal magnitude, opposite sign, so those two will negate each other. And these two consolidate. So that's a little less to memorize if you wish, but obviously it's going to waste a little bit of time if you just keep deriving it every time you come across this sort of situation. So this one is essentially that one. Yes. So you divide by 2, and then divide by 2. So 1/2 times the sum of those two is equal to the other side. So there it is. So not particularly a big deal in my opinion, but honestly, it's just nice if you just have this at hand to reference. And I think most teachers are pretty reasonable. I think so. I hope so. And then just to reiterate, these things will be extra, so we don't need to memorize those ones if you have to memorize. Let me delete this real quick. So just for less visual clutter, we can pretty much omit this one. And then we could omit this one as well, since it's combinable with the third one for the most part. So here it is. So in essence, we just have to deal with those ones in particular, and then we should be good to go. Alright. So it is kind of a hassle, unfortunately. If you must memorize it, then I just suggest doing a lot of problems until eventually you internalize it. But again, I believe most teachers don't expect you to memorize these. At least most. And then we're just going to open up by doing some problems, of course. And then there's going to be a variety of ways to go about doing some of these problems. And we'll cover the multiple ways. So first problem up, we have 2 times cosine of pi over 4. And then cosine of pi over 12. So because a lot of these properties, like these properties right here, they're pretty much derived from one ultimate source, many of the times you can use other avenues to complete these problems. So this is an evaluation problem. You might notice a few things. Number one, this is something we already know how to do. So that's just the triangle in the first quadrant. So we can definitely evaluate them by itself. But then this one is something that we're not totally familiar with, kind of, but yes we are. So what we can do is we can take this argument for the second cosine and then we could maybe break it up, right? So we can split this one. This is technically 1 pi over 12. So thus we can split it into 4 pi minus 3 pi. Using the tricks of the trade from before. And then we can expand this out. So let's do it like this first. So if we absolutely want to avoid using these properties in particular, then this is a problem we can get away with having to do it. And again, we're just going to go over that real quick for this one. But the main point of today is to actually do the property. So we're going to go over the prior method, and then we're going to use one of these shortcut, quote-unquote shortcut methods. So again, we're dealing with this one in particular. So we can expand the second cosine into this one, and then we can use one of our expansion rules for this one. And then this is one we already know how to evaluate, so we'll just leave it alone. So this one, we have what is that? That's 4 pi over 12. It splits up into 4/3. And then this one is 3 pi over 12. So with a subtraction between those two. So pi over 4. And then we could just use our expansion rules for this one. Cosines, keep them together, flip the sign. So we have cosine pi over 3 times cosine pi over 4. Flip the sign. And then we have the sine functions together. So sine pi over 3 and then sine pi over 4. So all the stuff we know how to do. And then this one right here, just copy paste that. We're not going to evaluate it just yet. Copy paste it too. Alright. And now we just need to sketch out the reference triangles. This is going to be pi over 4. And thankfully we have a lot of pi over 4s. So we can kind of save some work. So that's in quadrant number 1. It's a ratio of 1 to 1 to root 2. This is the 45, 45, 90. Opening up to the wide side in quadrant 1. So it's going to be root 3 to 1 to 2. Now let's evaluate each. Copy paste it 2. Cosine of this one is just root 2 over 2. Let's just cross it out for clarity's sake, and then we have cosine of pi over 3, which is just going to be 1/2. Be careful of the multiplication. This one should technically be in the brackets because this is a plus. Don't want to be too careless, so let's make sure we put the brackets here and there. So this is not being multiplied directly to this one only. We do need brackets. Alright. So this one evaluates into that one. And then this one evaluates into root 2 over 2. So done with that. This is a plus. Sine of pi over 3. Root 3 over 2. And then sine pi over 4. A lot of recycled numbers, of course. And then we just got to deal with the rest of this nonsense. So cancel 2 with this 2. Combine those. Combine those. This is denominator 4, denominator 4, and this is plus, so we can consolidate those two. This one with that one. We still have an awkward root 2 on the outside of the brackets. And then we'll distribute. Well, not to the bottom, just to the top. Alright, so root 2 times root 2 just gives us a clean 2. And then root 2 to 6 gives us root 12. Well, you know, you could grab a 2 from the 6, combine it with this one, and then we could take the square root of that. So, just to show a little bit of work, the root 2 times the root 6 gives us root 12, because they have the same exponent. And then this one, we have a 4 buried in there. That's a perfect square. 4 times 3. We take the square root of that one. Square root of 4, it's just 2. The 3 is left over in the radical. And we have a 4 on the bottom. And I think we're done with this evaluation. Yep. So it's going to be... Oh no, simplify this please. Divide by 2, divide by 2, divide by 2. So it's equal to 1 plus root 3 over 2. So that should be the answer using our standard root that we currently have. So if you absolutely want to avoid memorizing new stuff, then we can actually get the answer, at least with this type of problem, right? So this is not like one of those prove the identity properties problems. This is just simply evaluate. And these numbers are pretty nice, including this one. Alright. But that's using old method, so you could see how long that took. It took a good number of steps, right? From there to there. And I skipped like a couple, like... I didn't really skip that many steps, no. Alright, but that's how long it took. So, let's actually use one of those ones, right? And then there are basically two ways to use them. So this one right here, we have a cosine times a cosine. So we can use the product to sum situation. And you know, it's kind of a weird situation because we have cosine times cosine. This one is cosine times cosine. But then if you look at this one, this is also cosine times cosine. So the question is, which one should you use? And honestly, this one is going to be the easier of the two. So the procedure is, if you're given something in one of these forms, then this one is the easier to use compared to this one. So if you're starting off with the product, then I would use one of these ones right here. If you're starting off with a sum or a difference, then use one of these ones right here, following this algorithm. But the funny thing is, we can actually use this one directly on this one, because they're literally like derived from the same source. So as a result, they have pretty much the same utility. It's just that this one is rearranged just a little bit. Like there's some back substitution to change this into this form versus something like one of these ones right here. But again, for the most part, they're derived from the same source, so they have similar utility. But long story short, if you see trig function times trig function and you want to use one of those properties, then pick this algorithm. So let's see. So again, we have the cosine times the cosine. So we're going to use that one in particular. And let's just color code this real quick. So that's going to be the first argument, and then that one is a as well. That one's a. And this is going to be the second argument for the second cosine. So there's b, and then there's b. So denote the argument. We do have a very awkward 2 in the front, but that's okay. So no 2 coefficient in front, but that's fine. We should just keep the 2 separate. So in essence, what we're going to do is that we're basically going to just work on this portion by applying this algorithm to it. And then we'll deal with the 2 afterwards. So well, that's the plan anyway. Let us get started with the execution of the plan. So again, we're taking everything inside the brown box. Everything inside the brown box matches perfectly. So we're just going to copy paste the formula, the algorithm. So it's going to be 1/2 times cosine of blue plus red. So that's going to be blue plus red. So this is denominator 12. This is denominator 4. So top and bottom times 3. And then 3 plus 1 is 4. So immediately we're going to get 4 pi over 12. That's for this portion here resolved right there. We could of course simplify this in a moment. But let's get to the second part. So we're now dealing with cosine of the difference between blue and red. So cosine, we're going to copy paste the plus. Cosine of the difference between the 2 arguments. So this one minus this one. And again, this is going to be 3 over 12 equivalents. So 3 minus 1 is 2. So thus we get 2 pi over 12 before simplification. So all of this is happening inside the brown box, but don't forget we have a 2 on the outside. So just for visual clarity, we'll put the box and then we'll put the 2 on the outside. So that is there, and then this one gets applied to this algorithm, thereby getting us this one. And of course there's a bit of things to clean up. This one is just going to be pi over, what is that, pi over 3. And then this one's just going to be divided by 2, so pi over 6. And those are very familiar faces right there. The 2 here cancels out with the half, so that's gone. Okay. Now we just got to resolve this one. So this is an easy reference triangle. So it's going to be quadrant 1, opening up to the large side, root 3 to 2 to 1. So cosine of that is 1/2. And then this one right here is probably going to be this one, if all goes well, right? So that's going to be the slim angle opening up to the slim side, which is just 1. We have an adjacent of root 3. Hypotenuse of 2 ratio. Alright. Cosine of that, root 3 over 2. Common denominator, of course, so just sum the top, so 1 plus root 3 over 2. And as you see, the two answers are consistent. There they are. But the thing is, look how fewer work that took. Because we have this slightly more specialized formula, we're able to pretty much resolve this problem. We can resolve it with that much work, as opposed to all that work right there. So that's the advantage of having these very specialized shortcuts. They're not tremendously difficult. I mean, they're not tremendously useful, honestly. Because again, they're all derived from the same source. But, you know, a little expediency, what's the word? A little more efficiency is a little nice if you have the reference. Okay. So that's going to be the first problem. Again, you could use either of those two methods. The second one, using this specialized formula, is recommended. But we could also use this one on the situation as well. And I'll show you how to do it. So, starting over again. So we have 2 times cosine pi over 4. 1 times cosine of pi over 12. And we know this is going to be the answer from the prior two roots that we've already taken. So we're starting from right there. Again, with a product, I would recommend just jumping straight using this algorithm right here. But we can jimmy jam this one into this situation if we really wanted to. So you see how there's just 2 there in front already. And then we have a cosine of a thing times a cosine of another thing. So it does match form, but we just have to jump through a few more hoops. We got to transform this argument into something like this, and then this argument into something like that. So it's kind of a little bit more annoying, but it's not tremendously more annoying. So here's basically how we can do this. So we know that this entire thing is essentially that, right? So the question is, how do we force jam that one? So what's the best way to do this? I think we need to change them to at least match denominators first, right? This is denominator 2, so you know what? No. Let me think about that. What's the best way to do this? Yeah, we could just transform this one. So basically we're going to transform this one and this one to match this one and that one respectively. So we want to make this equivalent to with a denominator of 2 in the bottom. And the way to do that, we're simply going to have pi over 2. Smaller fraction over larger. So this one, again, since we have fraction divided by a number, then it ends up this number gets multiplied to this one. If you recall the goofy flip trick. So fraction divided by fraction. This one, we have to take the reciprocal. Those two multiply, back to come this one. So same algorithm on this one. We wish to achieve a 2 in the denominator, so we can match this one right there using this one. And of course the number is just going to be 12 divided by 2 is going to be 6. So pi over 6. So all we did was we transformed those two arguments to match up with the algorithm right there. And of course this is just one term, but we need to split this one and that one into a plus b and a minus b. And we could just do algebraic manipulations for that one. So this one is going to be the sum of a plus b. So just do a plus b as equal to pi over 2. And then that one is just going to be the difference between a and b. Alright, so there it is, and of course this is a system of equations. We have equation number 1 with a and b, and then we have equation number 2 with a and b as well. So 2 equations, 2 unknowns. We can solve for each unknown. So the easiest thing to do is do elimination. Equation number 1 plus equation number 2. Those two cancel out very nicely. And then those two sum up to be what? This is going to be 3 pi over 6 equivalents. So 3 plus 1 is 4. There it is. We can simplify this, divide top and bottom by 2. So we get 2 pi over 3. And then divide by 2, divide by 2. So A is equal to pi over 3. And of course, we can backplug this in to solve for the second unknown. If A is equal to pi over 3, then all we need to do is subtract B, and then we're going to get pi over 6, right? So we're going to do the old swapperoo right here. And we'll change this one into denominator 6. So 3 pi over 6, and then we're going to subtract this one from both sides. And we're going to add b to both sides. Whoops, it looks like a 6. There's the b. Alright. So 3 minus 1 is 2. So we have 2 pi over 6, which, that's kind of weird. We get pi over 3. Did I do that right? I'm sorry, not pi over 3. Wait. Hopefully I didn't goof something up. Let me double check something. Yeah, A is pi over 3, and then... Oh, I multiplied this incorrectly. Whoops. Pardon my mistake. Whoops. Okay, so again, this is going to be pi over 3. This is pi over 3, and then the equivalence of this one, top and bottom, times 2, times 2. So I put a 3 here and when I'm supposed to put a 2 right there. And then we're subtracting this one from both sides, and we add the b to both sides. Alright, now it makes sense. So 2 pi over 6 minus pi over 6, that's going to be equal to b, which is equal to pi over 6. So already you can see it's not worth it. Look how much work we have to do when the prior method with this one took only like 2 or 3 lines. Now we have a lot more lines right here. But that's okay, this is just an exercise. So we have this sort of situation. We are splitting this first argument into this one plus that one. And we'll copy paste the rest. So copy paste the 2 times cosine. And then we're going to do the a plus b divided by 2. So a plus b divided by 2. Alright, and then the second part right here, that's just going to be a minus b, which is just this one, with a minus between those two. So a little bit tedious, but not super difficult. There we go. And then now, well, basically, where are we, right? So we basically started off here. We transformed it to better suit this particular template. It wasn't perfect, though, because this one has one term. We need to have a plus b. So then we did a system of equations to split this one and split that one. And then now that takes us to right there. So now this one perfectly matches that one. And we're doing all that so we can transform this one to match that form. So a cosine of a plus cosine of b. Cosine of a plus cosine of b. Even the 2 gets dropped. So cosine of a plus cosine of b. And if you have good memory, this is actually one of the steps we had using the second root. All right. So that one's going to be the wide angle opening up to the wider side. So it's going to be root 3 to 1 to 2 in quadrant 1, and then this one opens up to the slim side. So 1 to 2 to root 3. So cosine of this is 1/2. And plus cosine of that one is root 3 over 2. And of course, it is consistent with what we got before. So 1 plus root 3 over 2, which is consistent with the prior answers right there. And it should be, because again, essentially they're all derived from the same source. But this is rearranged in a less optimal form to dealing with this problem, and then this one is arranged in a more optimal form to deal with that one. But you could use either, honestly. But you ask yourself, do I have the time, and is it worth it? Probably not, right? And that takes care of the first problem. We did 3 main roots on that one. We did the old stuff, and then we did the new algorithm right here, and then we also used this algorithm right there in reverse. So just to reiterate, if you see something that's in multiplication, a product, then please use the product to the sum. Don't use the sum to product one going backwards. It's not worth it, as you just saw. So I'm scratching out that problem, and then next up we have 4 times sine pi over 4, and then that's times sine of 12. These numbers look awfully familiar. I think we literally just done this problem from before. That's okay. It's now sines instead of cosine. We're just here to do the practice. So we're starting off with a product. So it's sine times sine. So use one of these. Don't use this one going backwards, because then that's going to take longer. Sine times sine. So sine times sine. We're going to use the second one in particular. And then we're just going to force this one to match this configuration as much as possible. So this is the part that already matches this one. So the 4 in the front, we're just going to leave it off to the side, and then we'll deal with it afterwards. We have argument number 1. And then we have argument number 2. And make sure we just follow form. So the 4, I'm going to copy paste it, so this thing will be in brackets. That's the one to which we're applying this particular this algorithm. So let's apply the algorithm. It's very simple. So sine of A is that one. So we're just going to apply the copy paste the 1/2 first. So 1/2, we're transforming the inside of the brackets. So the inside of the brackets should transform to 1/2, and then times the rest of that junk. So cosine of A minus B. A minus B. So mismatched denominators at the moment. And then this is going to be minus cosine of A plus B. Plus, plus. Not exactly the most riveting type of work. But at least these numbers are repeated. So if you match this one with this one, then you could straight up just copy your work, carry it over to right there. So that one top and bottom times 3 gives us 3 pi over 12. So again, we could just steal that and put it like right there. So if you want to save time, I'm just going to put instead of writing cosine fully, I'm just going to write this for now. Okay. And then 4 times 1/2 gives us 2. This is a minus, so let's keep the brackets. Alright. So this part right here, 3 minus 1 is 2. And then 2 cancels partially with the 12. So we get pi over 6 in the end. Then we have a 3 plus 1, which is 4. 4 partially cancels with 12 with a 3 in the bottom, so this is pi over 3. And this is cosine, and then minus cosine. And then a times 2 in the front, but remember this is a minus, so make sure you keep it outside the brackets for now. Alright, we're at this particular stage. This is pi over 6, cosine. These are very familiar. We've just worked with those angles. So that's going to be 1 to 2 to root 3. This is the one that we care about to evaluate this one. So root 3 over 2 minus. Reference angle is the wide one again. So root 3 to 1 to 2. We just care about this one. That's the brackets. You have a 2 on the outside. Alright, so we know the 2 will distribute to cancel with each of those denominators, so final answer is going to be root 3 minus 1. And then we're done with this particular problem. So I guess I took a little bit of steps right there. So let's double check the answers. This is root 3 minus 1. We're going to use our old property, so we're just going to evaluate this one straight up, and then this one we know we can split this fraction into 2, and we'll use expansion rule for the sign. So this one, we know how to evaluate that one, we'll just leave it as is. And then this one, of course, like the previous split, we can just do 4 minus 3 it again. Because this one partially cancels, and then this one partially cancels. So again, splitting the 12 over pi into 4 pi over 12, and then minus 3 pi over 12. So there it is. Using our expansion rule on that one, copy pasting this one. So this is sine of A minus B. So it's going to be sine, cosine, cosine, sine in the brackets. Sine, cosine, keep the same sign, and then cosine, sine. Alright, there we go. It's a kind of a mess, but everything is in quadrant 1, very nice. So this is going to be 45, 45, 90, so it's 1 to 1 to root 2. This is going to be the wide angle. So root 3 to 1 to 2. Now just comes the tedious task of evaluating each single one. So that's going to be root 2 over 2. Copy paste the 4. Again, root 2 over 2. Bracket. Sine of pi over 3, root 3 over 2. Cosine of pi over 4, root 2 over 2. Minus cosine of wide angles, which is this one right here, so it's going to be 1/2. And then sine of pi over 4, root 2 over 2. Close the brackets. So what do we have? We have this 4 partially cancels with this one. These ones are combinable. This is going to be 4, and that's also a 4, so we can combine this one with that one. So those two multiply to become root 6 minus root 2 all over 4. We have a 2 times root 2 outside. This 2 partially cancels with that 4. And then we'll distribute this one to this and to that. So this times this. And this one times this one. And copy paste it 2. Alright, here we go. And then lastly, this is the one we've seen before. It's just, again, square root of 4 times 3, we can take the square root of that. That one stays inside. Minus 2 over 2. Everything is divisible by 2, so divide by 2, divide by 2, divide by 2. Final answer root 3 minus 1. So there it is. It took a lot more work, I think. Yeah, so we started from here, and then we went all around to reach root 3 minus 1. This one is a little more direct, root 3 minus 1, but at least the two answers are consistent. So we are good to go for the second problem. Crossing that one out. Next problem up. We have sine of pi over 12. And then it's going to be a product times cosine of 5 pi over 12. Yeah. So what's that going to evaluate into? Well, it is a product between two trig functions. It's the sine times the cosine. Do we have an algorithm for that one? Yes, we do. It's going to be this one. So sine front, cosine second. And again, it doesn't matter. So if this one had instead been written like this, then all you have to do is just manually switch this one back yourself. So again, if the problem was written like this, because it's multiplication, you can multiply in any order you wish. A times B is equal to B times A. So it doesn't matter. So we'll keep it like this because the sine's first and the cosine second. It already matches this one. So we are good to go. So that's the A. And then that one's the B. Just for visual clarity. Alright, all we have to do is just follow the algorithm, right? So we are given this thing. There aren't any wacky coefficients in the front, so this one matches that one perfectly. So we could just jump straight to the template. So 1/2 first. Parenthetical sine of A plus B. So sine of. And thankfully the numbers are already nice. This is already this is denominator 12 and denominator 12. So 1 plus 5 is going to give us 6. So if you wish, you could just go ahead and simplify that one right away. That's just pi over 2. Follow the rest of the algorithm, of course. It's going to be plus sine of the difference of those two angles. So plus sine again. And then we'll do A minus B. So 1 minus 5 is negative 4. So again, you can just simply simplify that one as is. So we have 4 divide by 4 divide by 4. We get pi over 3. Now, if you know your evens and odds properties for sine functions, you could just take this negative and then yank it outside. But if you don't, it's not a big deal. So here we are. Close parenthetical. Here we are. This is something we can evaluate, and then this is also something we can evaluate. So let's get to evaluating. This one's going to be the classic interquadrant angle, the one pointing upwards. The quote-unquote collapsed triangle, where we have the opposite matching the hypotenuse in terms of the magnitude. But it's going to be 1 to 1. So this one evaluates to 1 over 1. Copy paste that. And then plus. This one has a negative, so, make sure you follow the conventions. We are rotating to create an angle that is clockwise from the neutral. So this is going to be neutral, clockwise, with the wide angle opening up to the wider side. So that's negative root 3 to 1 to 2. So what's sine? Opposite over hypotenuse. So there we go. At this point, I think we have everything down. So this has been evaluated, and then that has been evaluated. So now comes the task of just combining things together. This is denominator 2. So times 2 times 2. Sum up those two, so we have 2 minus root 3. We know we keep the same denominator, but we have to multiply it by 1/2, so this one gets changed to a 4. And if all went according to plan, then this answer should be correct, and then we're good to go. So, not too many steps. I know I kind of cheated just a little bit. I simplified it ahead right here. You know, like when we had the 1 pi over 12 plus 5 pi over 12 gives us 6 pi over 12. You can just jump straight to this one if you wish. Or if your teacher requires full work, then you do that one, and then you have another line right here. But all in all, not too many lines, as you see. It's just going to be maybe 1, 2, 3, and then 4 lines with a little bit of reference triangle sketch. So, fairly efficient, but also fairly specialized equations, which I never cared for those. So here it is. Alright, but let's practice just a little bit more. If you're interested in practicing the old expansion skills, we could also do it for this problem. So this one, again, circumventing having to use this particular property, we're just going to use our classic expansion rules. So we're going to split that. The difference must be 1, and then it has to share factors with the 12, so we have a 4 plus a 3. Or 4 minus 3 again. So we have 4 pi over 12 minus 3 pi over 12. That's the first split, and unfortunately this number is not nice, but we could also split that one, I think. So we can split that 5 into 2 and 3. Yeah, 2 and 3. So this is going to be 2 pi over 12 plus 3 pi over 12. So we're just using the less efficient route, but we're just trying to check this answer. So mod watchers, you could obviously skip this if you wish, but I'll make sure to timestamp it appropriately. Okay, so we have a sine expansion with a minus, so sine cosine minus cosine sine. Simplifying that into pi over 3. Simplifying that into pi over 4. Sine keeps the same sign. And then you could just steal those numbers, right? So that's the first expansion, and because this is a minus and this is a times, make sure you keep the brackets. Alright, and then this one right here. So cosine, you keep your cosines together. This one simplifies into pi over 6. That one simplifies into pi over 4. Cosine doesn't keep the same sign, so it's minus, and then we'll do sine sine. Copy those arguments. So a lot more smaller situations to reference the reference triangles. But, you know, we could still get the answer. So this is going to be pi over 3, which is, again, wide angle. 1 to 2. This is just 45, 45 in quadrant 1. So 1 to 1 to root 2. And that's all the reference triangles we need. Oh, no, right here. Okay, we need the slim one. Opening up to narrower side, so it's going to be 1 to root 3 to 2. This one we already have it right here. But I'm just going to draw it again. Alright, getting to evaluate those, we have sine, which is root 3 over 2. Cosine, which is root 2 over 2. Minus sine. Cosine of that is 1/2. Sine of that, whoops, root 2 over 2. It's the same as this one. Don't forget your brackets. Bracket, bracket. So times Cosine of that, root 2 over 3. I said it backwards. Root 3 over 2. Cosine of that one. Are you tired of these numbers? Sine of that one is 1/2. Root 2 over 2. So that's a lot of work, right? Already we can see that it's a lot less efficient than just straight up using this one. But we're getting there. So the common denominator is 4, so we just combine the top two. So this is going to be root 6 minus root 2 all over 4. Bracket number 1, bracket number 2. 6 over 4 over 4. So we just combine those two, and then minus root 2 all over 4. Alright, so it looks a little different than our first answer, doesn't it? But we haven't fully resolved everything. So we have 4 times 4 on the bottom. And then I guess this is practice working with the radical stuff. This is just a binomial expansion, so this one times this one. And then that one times... Let's do the middle term. So it's going to be this one times this one, and it happens twice. So it's going to be minus 2 root 12. And then lastly, negative root 2 times negative root 2. Do the sign digits first. So plus, and then root 2 times root 2. It's just 2. So everything is divisible at this point. But let's go a little farther. 6 plus 2 is 8. And then we could yank out a 4. Square root of 4 is 2. And then 2 times negative 2 is negative 4. We have a remainder of 3 all over 16. Everything is divisible by 4. So divide by 4. Divide by 4. Divide by 4. Does this match our prior answer? Yeah. So we are in agreement. And that's good, because that's a lot of work. So if it was inconsistent, that would be pretty bad, because there's a lot to consider. Where have things gone wrong? And of course, as mentioned earlier, we can force this one into this particular situation because it's a sine times cosine. But this strat going backwards from here to there, it ain't worth it. Even this method is better, but the first one was the most optimal one. Okay, moving right along, we have some other problems to contend with. Next up we have 1/4 sine. Sine of what? Pi over 24? Then we have cosine of 7 pi over 24. So we have a product, we have a sine thing times a cosine thing. So we're going to jump to one of these algorithms, not one of these algorithms. We have the sine times a cosine, so we're using the third one right there. So color coding it real quick again. We have second argument. That's going to be the B. And then we have the A. Alright, let's jump to the algorithm. This one, we have to match that one. We have a very awkward 1/4 in the front, but that's okay. We'll just leave it alone. So this one right here is the one that matches the form for the algorithm. So take that 1/4, copy paste it, and slap on the old brackets, and then we're going to apply algorithm to this one. So take that 1/2, put on the parenthetical, sine of A plus B. And thankfully these denominators already match up, so it's going to be 1 plus 7. So I'm actually going to leave this one here for now. And then we have a plus sign of the difference. So 1 minus 7 is negative 6. Alright, algorithm has been followed. All we need to do is just simplify things and then do the proper reference triangles and then evaluate. And we should be good to go. This one simplifies into pi over 3. That's nice. And then this one simplifies into what? Pi over 4. Don't forget the negative. Might as well work with that. So 1/4 times half is going to give us 1/8. But there's a plus here, so make sure you keep the parentheticals. Alright, easy reference angle. That's just going to be a wide angle. We've seen this one like 4 times or 3 times already. At least 4 times. Alright, so root 3 to 1 to 2. And this is going to be negative. This is 45, 45. Negative, so that's in quadrant 4, heading downwards like this, with the opposite of -1 ratio to 1 to root 2. So all reference triangles are sketched out. Let's do the evaluation. So sine of this one, root 3 over 2, plus opposite over hypotenuse. So negative root 2 over 2. Alright. Not much to be done. Summate those two. And then we have a common denominator of 2, but that gets multiplied to the 8, so it becomes 16, and then we should be good to go. And that takes care of that particular problem. And, you know, just to force the additional practice, if you wish, you can follow along, or you can just skip it on the VOD. We're not going to use expansion rules on these ones individually. Let's try to force this algorithm in reverse to this one, just so we can have some of a quote-unquote independent check on this one by using a slightly different strat. But again, ultimately, they are all derived from the same source. But here we go anyway. We have the sine times the cosine, so this is sine times cosine. This is cosine times cosine, so not this one and not this one. This is the one that match. We could try to force match those two. So just to reiterate, this is the less efficient route. Please use the first one. But this is just for, I guess, bonus practice, right? Alright. So the first thing to note is we have a coefficient of 1/4, but this one demands a 2. So we can split that 1/4 into 1/8 times 2. So now this matches this one. And then, of course, these two arguments don't match this one nor that one. So let's get to matching those ones. And by a quick evaluation, since this one here, this is 1 pi over 24, this is 7 pi over 24, this is the greater of the two. So this one must be the a plus the b, if we're considering positives only, and then this one must be the a minus the b. Alright, so let's force the match. This is 24, this is going to be 2. So 24 divided by 2, it's 12. So it's going to be sine of 1 pi over 12 all over 2. Again, the reason why we're doing this nonsense is so that we can just match it right there. So same strat right here. It's going to be cosine of, divided by 2 is 12. So 7 pi over 12 all over 2. This has to be a plus b, and this is going to be a minus b. Again, assuming everything's positive. It doesn't have to be. You could do this as a minus b if you wish, and this is a plus b. It doesn't matter. So a plus b. I just like to keep things as straightforward as possible. Pi over 12, and then this is going to be a minus b. And then, so 2a is equal to that one. So that's 8 pi over 12. So that's just going to be 2 pi over 3. So divide by 2, divide by 2. So a is therefore pi over 3. Back plugging that one in there and matching the denominator of 12, top and bottom times 4. So a is equivalent to 4 pi over 12. And if you subtract b, it should give us this one. So I'm just going to go ahead and just swap those two. So minus pi over 12 should give us positive b. And then b is therefore 3 pi over 12, which is pi over 4. So again, this method is not worth it. This is just for exercise purposes. Alright. So we can simplify that. No, don't simplify this. That'll be undoing our work. We're going to keep the 1/8 on the outside. So times what? Times 2 times sine of a minus b. Well, technically we don't really need the setup, but I just want to make sure it looks exactly like this one. And then what else? Cosine of a plus b. Maybe we just copy these numbers, but make sure you put a plus. Alright, so keep in mind this is the sine with the negative, and then the cosine is with the positive. So sine with the negative, and then cosine with the positive. So we're going to end up minus between those two. So we're going to end up with sine of a minus sine of b. And we're going to be replacing the 2 times the sine times the cosine. So this whole portion there will be replaced with the algorithm. Since we perfectly matched the form, we can now go backwards from that algorithm, and we're going to end up with this one, with the 1/8 in front. So that's the a, so sine of a, and then that's the b, so it's minus sine of b. Don't forget the 1/8. And this is stuff we could easily evaluate. Root 3 to 1 to 2. This is the pi over 4, 45, 45, 90. Copy paste. Sine is root 3 over 2. Minus root 2 over 2. Alright, here we go. And then we have common denominator, so just subtract the top 2. Keep the denominator of 2, and then times the 8. And that should be the answer. Yep, they are good to go. So for the most part, just by a visual inspection, so this line of work for the first method, and then this line of work for the second method with the additional stuff up on top right there. So this is how much extra work we need in order to go backwards from here to there. So again, I keep saying this just to reiterate, if you see a product, just use this one straight up. Don't try to force this one in reverse. And that takes care of that particular problem. Alright, moving on, we have the next problem up. We have 1/2 sine of pi over 24. And times cosine of 19 pi over 24. This is a product of sine and the cosine, so we're just going to apply the first one of the first three algorithms. That one right there. There's an awkward 1/2 in the front. That's okay. We're just going to match this one with this one. So copy paste the 1/2 in the front. Now let's do the algorithm on that part. So another 1/2, so don't get confused. Don't think that we've already placed the 1/2. This 1/2 is from the problem. This 1/2 is from the algorithm. Alright, we'll do sine of a plus b. Thankfully they're already matched up. So 1 plus 19 is 20. And then plus sine of the difference of the arguments. So this one minus that one. So 1 minus 19 is negative 18. Close brackets. Now let's just jump straight. Well, not jump. Let's just get to simplifying. So top and bottom divisible by what? 4? Yeah, divide by 4 is 5. Divide by 4 is 6. So this is a nice friendly angle we're used to seeing from before. Plus. This is a negative, but that's okay. So again, for you people who already know how to work with even odd functions, you could just take this negative and put it out in the front, because sine is an odd function. But let's not do that. So divide by 3 is 6. And then divide by 3 is 8. Oh, we could divide that even further. So we can divide by 6. Yeah, divide by 6, divide by 6. So we get negative 3 pi over 4. Make sure we close the brackets, and then we'll do 1/2 times 1/2. So there we are. Again, this is something we're familiar with, but at least it's not in quadrant 1 anymore. This is going to be 5 is 1 short of 6, so it's going to be slim angle in the second quadrant. So positive 1 to negative root 3, but we don't care because this is just sine. I'll put it anyway. Hypotenuse of 2, and then this one is negative, so clockwise from the neutral, this is 1 short of half a pi. Half circle, I mean. So it's in quadrant 3. So we have a negative opposite and a root 2 hypotenuse. Let's get to evaluating. So sine of this one, 1/2. Sine of that one. Well, copy paste the plus first. So plus, evaluating this one. Copy paste the 1/4 on the outside. Brackets. Alright. Common denominator is 2, so just add those two. So we have 1 minus root 2 all over 2, but we have a times 1/4, so this is going to be 8. And then we should be done with the problem. No check this time. I'm feeling kind of lazy, so time to move on. Next problem up, we have 2/3 cosine of 7 pi over 24. And then times cosine 35 pi over 24. So the numbers are a little wackier, but that's okay. So we have a cosine times a cosine. Find the right algorithm. Let's use one of these. It's cosine times cosine, so we're using the first one. We we do have a goofy 2/3 in the front, so leave that alone. We'll just box off the relevant part for the algorithm right here to right there. Alright, so copy paste the 2/3 first. Apply the algorithm to that one, so put the 1/2 from the algorithm. Parentheticals, cosine of a plus b plus cosine of a minus b. So everything's cosine. So a plus b first. So what is that? 7 plus 35 is 42. Plus cosine. And then we'll do the a minus the b. So 7 minus 35 is going to be negative 28. Close the brackets. Alright. So those numbers aren't super nice. We can divide by 6. Divide by 6. And divide by 4. Divide by 4. Oh, we can do a little bit more. Whoops. So we can divide top and bottom by 2. So negative 2 pi over 3. Right? Wait, something looks weird here. That does not look right. Oh, I wrote 6 instead of a 7. Whoops, what am I saying? So divide by 4 is 7. Divide by 4 is 6. Yeah. Okay. I don't know what I was doing last time, but this one should be correct. Don't forget the other players. So cancel this one with that one. We have 1/3 on the outside. Okay, let's get to sketching the reference. So this one, 7 is 1 short of 8, which is full circle. So this is going to be in quadrant 4. 45, 45, 90. So negative 1 to 1 to root 2. Now this one is the clockwise. It's 1 past half circle. So that's in quadrant 2. Slim angle because of the 6 on the bottom. So 1 to negative root 3 to 2. Alright. So cosine of that one, root 2 over 2. Plus cosine of that one, that's going to be negative root 3 over 2. Close the old brackets and then times 1/3. Alright, we have same denominator, so we'll sum those two. Common denominator of 2, but then we have times 1/3, so that becomes a 6 on the bottom. And this answer should be good. Is it worth our time to use the other strat? Nah, it's not worth it. Let's move on. Let me take a quick sip. Alright. Next up we have a 6 times cosine. 19 pi over 12. Times what? Sine of pi over 12. So again, we have a cosine times a sine. It's a product of the two trig functions, so we're going to use this one. This one is out of order, so to speak. So be careful. So don't just follow this algorithm. Just don't jump straight to this one. We should rearrange them because then there will be different a's and different b's. So we can manually rearrange this one, so it becomes 6 We can multiply in any order you wish because this is thing number 1 times thing number 2 times thing number 3. And that should be equivalent to A times C times B. So again, multiply in any order you wish. And then now it perfectly matches this one. Everything is aligned. So that's defined as A. So we need to say consistent, and this is also A. Just for visual clarity. Okay. So again, this one here doesn't have a coefficient out in front, so we should take that 6 and leave it alone. So we're only applying the algorithm to this piece right there. So copy paste the 6. Brackets. Follow the algorithm. The 1/2 comes from the algorithm. What are we doing? Sign. They're both signs, and it's positive in between. Alright. So sine of A plus B. So that's going to be 20 pi over 12. If memory serves me correctly, it was plus, and then also sine. But now the difference between A and B. So we have 1 minus 19, which is negative 18. Negative 18 pi over 12. Close parentheses. Don't forget this one. Don't forget the brackets. Well, technically we don't really need this because we're not inputting this into a calculator, nor are we programming, so that's superfluous. Alright. So 6 times 1/2 gives us 3. And we should probably simplify this. Divide by 4, divide by 4. What is that? 5 pi over 3? Yeah. 5 pi over 3, and then plus. Top and bottom is divisible by 6. So divide by 6 is negative 3 pi over 2. That's an interquadrant angle right there. Close parenthetical. Alright. Sketching the reference triangles. We have this one. Double 3 is 6. This is 1 short of 6, so we are in quadrant 4 with the wide angle. So that's negative root 3 to 1 to 2. This one, that's an interquadrant angle, but it is negative, so starting from the neutral, this is going to be negative pi over 2. This is going to be negative pi. So that one is going to be negative 3 pi over 12. So it's the one pointing upwards. The quote-unquote collapsed triangle. Sine, this is going to be 1 to 1 with a positive. Alright. So sine of this one is negative root 3 over 2. Plus sine of that one, again it is 1 over 1, which will match it with this one. So 2 over 2. And of course, just summate those. I'm going to switch the order of, so it's going to be 3 times 2 minus root 3 over 2. And nothing to cancel, so the 3, I'm just going to distribute it. So we're going to get 6 minus 3 root 3 all over 2. That should be the final answer. Yeah, we're good to go. Alright, of course we should practice the other one. Let's not be too fixated on the first 3 algorithms. Let's do some problems that are pertaining to those ones right there. So first, let's clear that. And then now we're going the other way. So pay attention to the differences, or the sums and differences, or the products. So now we have a sine of a 5 pi over 12 minus, see, that's a big difference now, Sine of pi over 12. Okay. So now that we're dealing with this one, we recognize that this is not a product of two trig functions. So this is not a nice angle, kind of, and this is also kind of not a nice angle. This is the minus between those. So again, we're not going to be forcing this one in reverse. This one is optimal if we have a product. We don't have a product. So instead, let's use one of these ones. So sine minus a sine. Those are cosines. Those are cosines. We have to deal with this one. And remember, this is color-coded. This is going to be the minus one will be with this one, and the plus will be that one. So let's write this real quick. So we're dealing with the sine of a minus sine of b. That's going to lead to, following the algorithm, 2 times sine of a minus b first. And times cosine of a plus b. So we're going to take this template and then we're just going to move it over, scooch it on over, or copy paste. So is it in correct form? Yes, it is. Whoops, that's not the color I wanted. Red. Just to acknowledge it, we do have a minus in between. That's a minus, and that's a minus. So that's a minus. So we're good to go. Let's just copy paste the template. So transforming this one, because it matches this form, we're going to transform it into this following the algorithm. So copy paste that too from the algorithm. And then we have sine of a minus b over 2. So this one minus this one. 5 minus 1 is 4, so we have 4 pi over 12. But it is divided by 2. That's straight from the algorithm. Times cosine. A plus b now, so it's going to be 5 plus 1 is 6, so 6 pi over 12. Just from the ABs, but don't forget the algorithm has a division by 2. So divide by 2. So all the numbers are accounted for. The template has been filled. All we got to do is just get to simplifying. So you can proceed in any order, in whatever order you wish. I'm going to change this. I'm just going to divide by 2 first, because I like to follow some semblance of order. So I'm going to deal with the big division bar first to change this one. So it becomes 4 pi over 24. Yeah, technically I'm going to avoid writing this because this one is further simplifiable. So this one right here, again, the 12 times 2 is 24. Alright, and then again, these ones can further be simplified. So divide by 4, leaving us with pi over 6. That's in the sine function. Copy paste the 2. This is a times, so no brackets. Times. This one again, we have divide by 6 with inside the cosine. So it's going to be pi over 4. Okay, fairly nice reference angles. We have the slim one in quadrant 1, which is going to be 1 to 2. And then we have the 45, 45, 90. So that's 1 to root 2. Copy paste the 2. Evaluate this one. It's going to be 1/2. Evaluate that one. It's just root 2 over 2. Those two cancel, thereby leaving us with just root 2 over 2. And that should be the final answer. So not too difficult, these problems that we've done so far, but they are kind of annoying because we do need to reference these formulas, and honestly, I don't have a good mnemonic to memorizing these ones because I almost never use these. Now that's it for this one. And just for fun, VOD watchers, you can skip this. what we can do is we're just going to check this answer by using the expansion rules for this particular situation. So we're going to split this sine of 5 pi over 12. We're going to split the argument into 3 pi plus 2 pi over 12. So 3 pi over 12, and then plus 2 pi over 12. And then we have a minus here. This one we've already split that one, like I think that was like the first example we did. So 4 pi minus 3 pi. Alright, then we could use our expansion rule, sine, cosine, cosine, sine, with a plus. But, you know what, let's simplify this first. It's plus, and this one is a pi over 3. That's a minus pi over 4. Alright, now let's do the sine, cosine, cosine, sine nonsense. So sine of pi over 4, cosine pi over 6, sine keeps the same sign, plus cosine sine. Alright, so that one expands into that one. Wonderful. Minus, put it second line. Same strat, sine, cosine, cosine, sine. Pi over 3. Sine keeps the same sign, so minus. And since this is a minus, be careful, put in the brackets. And then cosine sine. That's a lot of work. Well, pretty simple reference triangles. Okay, that's for the first two terms, and then for the ones in the brackets. And this one's just the same as this one. Okay, so to evaluation, we have sine of that one, cosine of that one, and you notice I'm crossing things out because that's a lot to keep track of. It's plus cosine of that one, sine of that one, and then minus inside the brackets, sine of that one, cosine of that one, what was the signage? Minus. Cosine of that, 1/2. Sine of that. We're almost done. Okay, well. Root 6 over 4 plus root 2 over 4. Whoops. And then minus this one, so it's going to be minus root 6 over 4. And then minus a minus gives us a plus. That's going to be root 2 over 4. Wow. This one perfectly cancels with that one. And then this one plus this one gives us 2 root 2 over 4. Partial cancellation. Final answer is root 2 over 2. And that is consistent with the first answer. So that's a lot of work. So let's stick with the first method, right? Alright. Wait, which problem was that again? Sine. Okay. So now moving on, we have a cosine situation now. We have cosine of pi over 12 minus cosine of 7 pi over 12 Alrighty, we have a difference between two trig functions, so we have to use one of these algorithms. Cosine minus cosine, right? Yep. So the template, since we have this one, then we follow this particular template. So minus 2 times sine of a plus b over 2. And then times sine of a minus b over 2. So I'm just going to copy paste this one right next to this, so I don't mismatch something. So all we're going to do is apply this one to the template that was written right here and follow the directions. So the -2 from the algorithm times sine of a plus b. So what? So that's a 1 plus 7 is 8. 8 pi over 12. Then times sine of, oh, I forgot to do the divided by 2. Whoops. Hold up. Let's do it again. So 1 plus 7 is, we're ignoring this one because we're just following the algorithm right here. This one is already accounted for right there. So just add those two arguments. So 1 plus 7 is 8 pi over 12, but divide by 2, right? So I'm just going to jump straight to that one. So rather than have a 12 on the bottom, have a 24. And then we have the 8 pi on top. So again, I could have written this as this one minus this one and get like -6 pi over 12 first, and then put the big division sign. 2. But this one, I'm going to skip this particular step. So again, here's what's going to happen. 1 minus 7 is -6 over 12, and then the 12 times the 2 is 24. So there we go. We just got to simplify this. So divide by 8, divide by 8. Divide by 6, divide by 6. Alright. Reference triangles. Here we are again. It's a negative, it's in quadrant 4. Copy paste the -2 times, and then sine of this one is √3 over 2. Sine of that one is -√2 over 2. Negative cancels with negative, and then the 2 cancels with the 2, so just multiply those two straight up. So √6 over 2. And that should be the answer for this problem. And we're good to go. Perfect. And then next up, so what do we have right here? We have a sine thing times, not plus or minus, a sine thing. So I just threw this in randomly. Hope you were able to see it. So this is going to be a product, not a sum or difference. So not one of these. So we're going to default to one of those ones. we have a sine times a sine thing. So we're going to apply this particular algorithm. So this one right here. I'm feeling kind of lazy, so I don't want to write it, so I'm going to put this one right next to it. And then we'll just follow it accordingly. So again, this one matches this one because it's the product. Not a sum, not a difference. So it's just good to interrupt the problem like that once in a while. Okay, so following this particular template, the 1/2 comes from the algorithm. And we have cosine of A minus B. So that's going to be -6 pi over 12. That's a minus from the algorithm. And then cosine of A plus B. A plus B is 8 pi over 12. Close the parenthetical, closing it again, and now we can just get to simplification, so that becomes -pi/2, the inner quadrant angle, and then this one right there, what is that? Top and bottom divided by 2 is, I'm sorry, divided by 4 is 2 pi over 3. And copy paste the rest. Alright, there we go. This is interquadrant angle. It's the negative one, so it's the one pointing downwards. This is the collapsed triangle with quote-unquote no adjacent, so this one evaluates to 0. That one right there. That's also an interquadrant angle, right? No, it's not. This is over 3, not over 2. Alright, and this is in the wide angle. 2 is 1 short from 3, so this is in quadrant 2 with the wide angle. Opening up to the root 3 to -1 in quadrant 2 to 2. So we have a minus. And what's this one? -1 over 2. This negative is from there. This one is from there. Alright, so minus minus is plus, and then 1/2 times 1/2 is 1/4. So that should be the answer for this particular problem. So again, this is a goofy problem. It wasn't a sum or difference, so therefore we call upon this one. And that should be the answer, unless I really botched up something. Is it worth it to do the expansion? Let's do the expansion. So that should be the answer. So VOD watchers, you could skip this next part. But let's get to expanding this one as well. So we have 4 minus 3. Usual shenanigans, you know. So that's the first sign split of the fraction of the argument. And this one, we're going to split that one as well. That one splits into 3 plus 4, just like this one. But this is a minus. This is a plus. Alright, this one changes into pi over 3, and this one changes into pi over 4. So I'm gonna... Let's get the expansion right away. So let's do this one first. Sine, cosine, cosine, sine. Sine keeps the same sign, so it's minus, and then cosine, sine. So this first part is finished. And close the brackets. And this is now second factor to contend with. Also putting in brackets sine, cosine, cosine, sine with a plus. Plus. So fairly simple reference angles. We have the wide angle into the positive root 3. And then we have the 45, 45, 90 in quadrant 1 again. 1, 1, root 2. So sine of doing this one first. Root 3 over 2. Root 2 over 2. Minus 1/2 times root 2 over 2. Close the brackets. Second set of brackets, sine of this one. Wait, it's going to be the same thing, right? So we can kind of copy paste our numbers to be efficient. So this is sine pi over 3 cosine pi over 4. Yep. So we're just going to steal these numbers. In fact, let's just steal the whole thing. So we're going to take this one and then copy paste it. The only difference is the signage. So this is a plus. Alright, let's get to consolidating things. This is all going to be over 4. So root 6 minus root 2. Close the brackets. This one should be the same thing except with a plus. So root 6 plus root 2 over 4. Alright, we have a difference of 2 squares scenario on the top. So just multiply those two. We get 6. And this term combo, that term product will cancel out with that term product. So we ignore it, and then negative times positive is negative, and this one times this one, that's a 2. And then 4 times 4 is 16. Okay, so we have a 4 over 16, which simplifies into 1/4. And I think that matches. Yes. Alright. So we are confirmed. Next problem up. That's just to keep you all on your toes. We have a sine of 19 pi over 12. What is it? It's plus. So we have a sum to product. So we have sine of 3 pi over 4. At the moment, these ones are mismatched, so we should change this one, because might as well do it right now. Times 3 times 3. Okay. So again, this is a sine thing plus another sine thing. So it's going to be that one. With a plus in between, so we're going to keep a plus there, and we'll keep a minus there. So I'm going to copy paste this one. So this one already matches what we have with the plus, not the minus. So let's copy it with the plus and minus. So 2 sine of a plus b over 2 and then times cosine of a minus b over 2. So take that and paste it right here. So we are applying this algorithm to this one because this one matches the correct template for that one. Alright. Just to color code this shenanigan, this is going to be, that's going to be A, and that one's going to be B. So copy the 2 from the algorithm. Sine first. Sine of what? A plus B. So this one already matches this one because that's, we know we did it a little earlier. So 19 plus 9 is 28 over 12, but don't forget to divide by the 2. So over 24. Close parentheticals, and then next one, cosine. We now have a difference between those two. So 19 minus 9 is 10. And you notice I just jumped straight to the 24 because I copied it from here. And this one is prefaced on the fact that we already took into account this division by 2. on that denominator. Alright. Get to simplifying, of course. Divide by 4, divide by 4. That's perfect. That's what we want. And then divide top and bottom by 2. Oh, wait. Oh, did I mess up on this problem? I may have messed up on this problem. Okay, well, that's okay. This one right here, unfortunately, it doesn't change into something particularly nice. Divide by 2 is 5 pi. But divide by 2 is an unpleasant 12. So that one is nice. That one is not nice. So this one, we need to do an additional work on this one. And hope you can see it already. We can do decomposition on this one. So now it's relevant to do the decomposition. Because at the moment, we don't have the half angle formula, which is another derived algorithm. But we don't have it at the moment, so that's okay. We could just use expansion from this one. But this one is a nice situation. So let's copy paste those two. And then this one, we have no choice but to expand it. So we're going to split that. We're going to split that 5 into parts that are partially divisible by the 12. Portions of the 12. And 3 and 2 are perfect. So we're going to have 3 pi over 12 plus 3. I'm sorry, did I say 3? 2 pi over 12 plus 3 pi over 12. You can see here that this one changes into 1/6. And this one changes into 1/4, which is perfect. Alright, so kind of a nuisance, but kind of necessary without additional tools. So again, pi over 6 plus pi over 4, and those ones are very nice to evaluate. So we have to do the cosine expansion on this one. Don't forget to copy paste this one. Alright, here we go. This is the cosine, so you keep the cosines together. So it's going to be cosine of this one and this one. Sine keeps the same sign, not the cosine, so it's minus. Since this is the minus and this is the multiplication, make sure to put the brackets. Okay. So we're done evaluating the expanding that one, and now this one, copy paste. All right, and we need to just sketch the reference triangles. That's a slim one. So 1 to root 3 to 2. Classic 45, 45, 90 in quadrant 1. Whoops. And then this one is 1 greater than 6. So this is in quadrant 3. Slim angle again. So that's a negative adjacent, negative opposite as well. So reference triangles have been sketched. Let's get to evaluating. Copy paste the 2. Evaluate this one. That's going to be negative 1/2. And then we have the brackets. Cosine of this one, root 3 over 2. Cosine of that one, root 2 over 2. Minus sine of that, 1/2. Sine of pi over 4, root 2 over 2. What do we have here? 2 cancels with this 1/2, leaving us negative 1. Brackets. Multiply is root 6 minus root 2. Common denominator is 4. We have a sign flip shenanigans, so those two signs are going to flip. And so do a flip. Root 2 minus root 6 all over 4. And that should be the answer for this one. It's quite a bit of work. So the unfortunate situation was we did come across this kind of an awkward 5 pi over 12, but using our old tool of expansion, we can use our angle sum expansion for the cosine, and then we could get around to it to get to this final answer. So crossing that out, and then we're good to go. Yeah. Alright, so of this set, I think we have 3 more problems for the set. And we'll get to the algebraic situations. So now we have 4 times cosine 7 pi over 4. Make note that this is typically a nice angle. We can deal with this. But then we do have a plus 4 cosine of 13 pi over 12. That one is more unpleasant. We can probably expand that out, but let's just force one of our algorithms into play. So we have a sum of these 2 cosines. So not those ones. One of these. But we make note that this algorithm template doesn't have any coefficients in front. Those ones have a 4. So let's just factor the 4 from those 2. So 4 times cosine of 7 pi over 4, and then plus cosine of 13 pi over 12. Close the brackets. So now this one matches the template with the 4. We're just kind of leaving, kind of pigeonholing it right there. So now this one matches. Yep. So we'll copy paste this algorithm. You know what? I'm just going to move the work. I'm too lazy to write it again. So we'll take this whole thing, put it next to the algorithm. Yeah, okay, it's perfect. Alright, here we go. The 4 is on the outside. And then from the algorithm, that's where this 2 comes from. So don't steal the 2 from the 4. This 2 is from the algorithm itself, not from the 4. And then we have what? Cosine times cosine. Well, unfortunately, this one is mismatched with that one, so let me change this. Top and bottom times 3, so it's going to be 21 pi over 12. Alright, so that should make the job a little bit easier to summate those two. So 21 plus 13 is what? 34? 34 pi over 12, but don't forget this algorithm, you need to divide by 2. So the 12 one becomes 24. Alright. And then times cosine of the difference. So we're going to do 21 minus 13, which is 8 pi. So cosine of 8 pi. And we're going to copy this denominator. Because mechanically it should be the same. Alright. So we've achieved this form. This is simplifiable. So top and bottom divide by 2. And unfortunately that leaves us with a 12 on the bottom, which is not a nice situation. So this one requires additional work, unfortunately. The 4 times the 2 we could resolve, because this is just multiplication. And then this one is a nice one, however. Cosine of top and bottom divide by 8, so that's going to be pi over 3. So this is a nice situation. So that's nice, that's nice, that's unpleasant. We need to change this one. So we can split that into what? What's optimal split? We need to split this one so it can become, each of those split becomes partially divisible by this 12. So 15. I think I already said it. My brain. So we have 15 plus a 2. I think that works, right? Yeah, that's perfect. Okay, so we're going to split it into 15 pi over 12. And then plus 2 pi over 12. Because again, this angle is not nice. So we have to do this additional work on it, unfortunately. This is nice, so it's copy-paste. And that one becomes top and bottom divided by 3. That's going to be 5 pi over 4, which is perfect. That's what we care about. And then top and bottom divided by 2. That's also nice. And we're going to do a cosine expansion on this one. So it's going to be cosine, cosine, sine, sine. Flip the sign. And that is truly a hassle. That's a minus. And since that's a minus thing, you have to be careful. Now we need to put brackets. But sine, sine. Close the brackets times this one. Alright, here we go. We have this one. 5 is 1 greater than 4, so that's in quadrant 3. So we have a -1 to -1 to root 2. Pi over 6, slim angle in quadrant 1. Too many times today now. And then we have this one. The wide angle. So root 3 to 1 to 2. Alright. We can get to the evaluation. Copy paste the 8 in the outside the brackets. So cosine is negative root 2 over 2. Cosine of this one is root 3 over 2. Minus. We have sine of that one, which is going to be negative root 2 over 2. So that negative is right there. And this one comes from the ratio. And then sine of pi over 6, that's going to be 1/2. Close the brackets. Cosine of pi over 3, 1/2. So the 1/2 times the 8 is 4. So this is a minus minus, so that's going to be a plus. So it's going to be root 2 minus root 6 all over 4. 4 cancels with 4. Final answer is root 2 minus root 6. And that problem is complete. And now we have 6 times sine. Sine of what? 23 pi over 12. And then what do we have? Is it plus or minus or multiplication? It's minus. 6 times sine of pi over 4. Actually, I did want to make a note. This is actually very similar to the previous problem, right? Because this one, we can evaluate it straight up. And this one, we could just split it. I actually think that would have been the better strat for the previous problem. Because when we used the algorithm on the previous problem, it led us to a situation where we still have to do expansion. So I think we could have, just looking at this problem, right? I think it's better to just evaluate this straight up and then do the expansion for this problem. And I think that would make it a lot easier. But again, this is just for the sake of practicing these problems. So here we are. We do have a 6 out in front and a 6 out in front. None of the forms here have a 6, so factor out the 6 from those two. So divide by 6, divide by 6. So now we have sine of 23 pi over 12. And then minus pi over 4. Okay. So like I said, I suspect that expansion rule is a lot simpler for this one. We could split this 23 into what? Into 18, no, not 18 plus 5. That's a bad one. What would be a good split? 16, no. No, it's bad. I can think of a good split for that. Oh, I'm sorry, 15 plus 8. That's a good split. Yes. Yeah. So we could just jump straight to expansion for this particular problem. So I'm going to do the expansion first. Yeah, so let's practice the... No, let's go in order. I'm sorry. Let's go in order. I keep changing my mind. Okay, so this one, we're just going to force the algorithm, even though, again, my suspicion is that it's just better to evaluate this one straight up and then use the expansion rule on this one rather than forcing this algorithm. But, again, since we're practicing these ones, let's force the algorithm. So we have sine minus a sine. So it's going to be this one with the minus. So with the minus and the plus. So I'm going to copy paste this one with the minus. With the minus, with the plus. So copying the form, we're going to have 2 times sine a minus b over 2 times cosine of a plus b over 2. And that's what we're going to take. So cut that, and we're going to apply it to the inside of the brackets. It's not equivalent, so I'm going to offset it just a little bit like this. Alright, so copy paste that 6 because the 6 came from the original problem. This 2 is from the template, is from the algorithm. So 2, and then times that nonsense. So sine of what? This is a 12, this is a 4, so let's change this one into 3 pi over 12. Alright, so a minus b. So that's going to give us 20 pi over 12. Alright, so we're done applying this first part. Oh, no. Don't forget to divide by 2. So not over 12, over 24. Alright. Now that's done to the first term. So that's done. That's done. This is done. And then we just did the 2 to the 12. So that one's done. Alright. Times, following the algorithm, cosine of a plus b. So it's 23 plus 3 is 26. I'm going to steal the work. Close the brackets. Alright. So we can just distribute this one because it's all multiplication. 12 times. Simplify this nonsense. Divide by 4, divide by 4. Divide by, yeah, this is a bad situation. Yeah, you see this? We're going to get 13 pi over 12. So the algorithm has failed us because it wasn't any faster than the hypothesized route. So this one, we have no choice but to expand this one out as well. That's okay. This is just practice. So we're going to split that into what? 4 and 9? Yeah, 4 plus 9 is 13. 4 cancels with the 4 and the 12, and then 9 partially cancels with the 3 and the 12. That's a good split. 4 and 9. Alright. So you have 9 pi over 12 plus 4 pi over 12 inside the cosine. So I'm just going to go ahead and simplify this right away. So it's going to be 3 pi over 4 plus pi over 3. That's inside the cosine. These ones are already nice, so we're going to leave them as is. So using the cosine expansion, cosine, cosine, sine, sine, with a minus, because we're going to flip the sign. So cosine 3 pi over 4 times cosine pi over 3. Change the sign because it's not sine. And then sine 3 pi over 4 times sine pi over 3. Since this is a minus, make sure you put the brackets. Okay. So that's done. Copy pasting those 2 factors. And then we just get to evaluating this nonsense. This one is slim angle in the second quadrant. Whoops, almost messed up. Yeah. That's why sometimes it's useful to write this third one. And we have 3 pi over 4, which is in quadrant 2. quadrant 1. Alright, evaluation time, we copy paste to 12. Sine of that one is going to be 1/2 times bracket part. What do we got? Cosine of this one, negative root 2 over 2. Cosine of that one is just 1/2. Minus, and then sine of this one is going to be, wait, which one is it? This one. So root 2 over 2. Sine of pi over 3, root 3 over 2. Alright, so half of 12 is 6, bracket time. Unfortunately, they're both minuses. So, minus root 2, minus root 6, all over 4. So that one partially cancels with that one, and the 3, we can distribute it to those two. And thus do we get negative 3 root 2 minus 3 root 6 all over 2. Hopefully that's the right answer. That looks wrong. I'm going to have to check that. Let me punch down the calculator real quick. You know what? Let's not use a calculator. Let's use the other method. So this answer is maybe dubious. I'm not exactly sure, because I think I have an answer sheet, but this one doesn't match that one. So there may be some mishaps somewhere along the way. So I don't fully trust this answer. So we will accept it tentatively. Let's actually do the other strat as suggested before. Alright, so this one we can already evaluate, but this one we cannot, because 12 is not one of those nice angles. So we can do the manual split for this one. So let's do it straight off the bat. So copy paste is 6, and then we'll do the sine split. What did we say again? 4 and 9? Yeah, 4 and 9. So it's going to be 9 pi over 12 plus 4 pi over 12. Because 9 plus... Oh wait, that's not right. I'm sorry. 9 plus 4 is 13. What am I saying? Easy fix. Yeah. Okay, and then of course this one we copy paste. We can evaluate this as at any moment we wish. Alright, this one is simplifiable, so that's going to be, what is that, 3 pi over 4. This one is 7 pi over 12, over 6 I mean. And we'll just use the cosine expansion on that one, so it's going to be copy paste to 6. Put the brackets, because it will be plus. We have sine, cosine, cosine, sine. So sine, cosine. Keep the same sign. Cosine. And then sine. Alright, that's the entire expansion. So we close the brackets and then we'll copy paste this one. Alright, getting to evaluate this one. This one is in quadrant 2. So -1 to -1 to root 2. This one is in quadrant 3, slim angle. So -1 opposite, negative root. Oh, this is positive. Whoops. Almost goofed that one up. So negative root 3 to 2. Yeah, this is going upwards, so it's positive. Okay. These are both negative because it's going to the left and going downwards. Yes. So that should be that one. Okay. And lastly, this one is just standard position. Quadrant 1. Very boring. So getting to evaluation, of course, we have the 6 times what? Inside the brackets first, we have sine of this one, which is root 2 over 2. Cosine of that one is negative root 3 over 2. We have a plus. And cosine of that one, negative root 2 over 2. Sine of that one, negative 1/2. Close the brackets. Minus 6 times what? Sine of this one, root 2 over 2. Alright. So, let's resolve this. That's going to be negative times negative, so that's all positive. So this is going to be positive root 2, and then minus root 6, all over 4, times 6, brackets. And this one, this is a minus, not a times, so 6 partially cancels with a 2, giving us a 3 root 2. Partial cancel, partial cancel. We can use the distributive property, so we're going to get 3 root 2 minus 3 root 6 all over 2. And then this one, we can combine it with this one by multiplying top and bottom by 2, so minus 6 root 2 over 2. And this one is combinable with that one, so negative 3 root 2 minus 3 root 6 all over common denominator of 2. Is that matching up? It does match up. Oh, interesting. Alright, so in conclusion, yes, this is the correct answer. It should be correct unless I consistently made a mistake the second time around, but they look good. That's good enough for now. You know what, my paranoia is setting in. Hold on. Let me just input this in the calculator for final check. Wait, where's the problem? The problem was 6 sine of 23 pi over 12 minus 6 times, I mean, it's not 6. It's like, oh yeah, 6 times sine of pi over 4. And according to the calculator, it's going to give us, I cannot tell, alright, so calculator will report negative 3 root 2 minus 3 root 3 minus 1 over root 2. So they kept the irrational on the bottom. Let's just check, because I'm a little paranoid, so watch out for those double negatives. I guess this is just a review of radicals, right? So first we're going to rationalize this nonsense. So root 2, root 2. So the bottom part becomes 2. And then the top part becomes 3 root 6 minus root 2. We have a distributive property to negative flip and positive flip. So this becomes negative and that becomes positive. This one will make common denominator match with the 2. It's currently over 1, so top and bottom times 2. So negative 6 root 2 over 2. Alright. So what do we have? Did I mess something up? Something looks wrong here. Yeah. Okay, that should be correct. Okay. So again, this one negative is now here, and then this negative times this negative gives us the positive there. So these are combinable with a plus. So we'll copy paste the negative 3 root 6, and then this. Ooh, that's weird. Okay, that does not look good. So that looks different. So what has happened? So the answers look correct for the most part. So let me see the calculator again. Oh, I miswrote down the calculator. Okay, it's good. The answer is good. And the reason what happened was this. Okay, hold on. So I wrote that incorrectly from the calculator. What the calculator said was 3 parentheses. I forgot to put the parentheticals. So it's going to be root 3 minus 1, close parentheses, root 2. So top and bottom times root 2. And you can see this one's supposed to distribute. So it's going to be 3 root 6. 3 times negative 1 is negative 3. And then times this one is negative 3 root 2. Yeah. So that's where things went wrong. And then this is the minus, so this becomes minus and a plus. This one, negative 6 root 2 over 2. And copy paste the negative 3 root 6. And then combine these two like terms. So that's negative 3 root 2 all over common denominator of 2. Which matches the first answer and thus the second answer. So all that work for no reason. That's okay. It's good to be safe. Alright, let me take a quick sip. This is probably going to be the last problem. We will have to save the algebraic portion for another time maybe. Or maybe not. I'll think about it. Let's see how things are. So as long as things proceed swimmingly. Alright, we have sine of 23 pi over 12. And then minus sine 5 pi over 4. So what is this? So we can potentially have some sneaking suspicions. This one we could evaluate. This one we could probably split. Honestly, it's probably better to go down this route. We can split that this 23 into same numbers as before, 16 and 8, right? No, 15 and 8. 15 and 8. So we'll probably do this strat just to check the answer, but honestly, I think this route is the easier route to take. But let's avoid that for now, and let's just force the algorithm. So what are we doing? We're doing the last one with the minus, so let's go right here. Alright, let's just follow the template. This is going to be a minus, so that one is going to be a minus, and then this one will be a plus. And we might as well get to changing this one into a 12. Okay. So let's change this one as well. It's going to be top and bottom times 3, so we have 15 pi over 12. Just to make the addition easier right off the bat. Okay. So, applying the algorithm, now that this one perfectly matches this one, just jump straight to the template. We have a copy and paste the 2 from the algorithm, and then sine of what? A minus b. So 23 minus 15 is 8 pi. Don't forget the algorithm has division by 2, so not divided by 12. 12 times 2 is 24. So first portion is done, and the 2. Now we have the cosine. Cosine of what? A plus b. So 23 plus 5 is going to be 28. All over what? Copy paste this one. Alright. So the worst is over. Divide by 8. Divide by 8. That's a nice angle. And then divide by 4. Divide by 4. Oh, that's also a nice angle. Good stuff. So 7 pi over 6. So we don't need to do expansion, and we don't need to do expansion. So thankfully, we have less work to do. So this is actually optimal path. So sine of that. We're so used to this one now. And then cosine, this is 1 past 6, so that's going to be in quadrant 3. All negatives for the adjacent and opposite. Not the hypotenuse. Alright, so we have 2 times sine of that times cosine of this one. Alright, so what do we get? This one cancels with this one. We have a negative in the end. We have root 3 times root 3, which is 3. There's a 2 left over on the bottom. So, well, this is a very clean answer. That's kind of unexpected, honestly. But is that correct? Unfortunately, I don't have an answer key for this one. Okay. But just following the algorithm, it should be correct. But let's point out that this one should be the correct answer. Let's use the alt strat for this one. So this is the problem we're dealing with. We can evaluate this one fairly straightforward. This one we can do the decomposition. So let us do it right there, right? Yeah. So minus sine 5 pi over 4. So this is just to check the work. We can split that one. What is that? Top and bottom is divisible by 3. So 5 pi over 4 plus that one, top and bottom divisible by 4, so 2 pi over 3. And that one we'll just copy paste. Alright. This is a sine expansion, so we have sine, cosine, cosine, sine. Keep the same sign. Do we need parenthetical? Nothing's being multiplied, so we just copy paste this. Here we are. Oh, that's very nice. Those three match up. So that's going to be, again, that's in quadrant 3. Because 5 is 1 greater than 4. And 4 is a 45, 45, 90. So minus 1, and then root 2. This one is 1. That's 1 less than this one, so we're in quadrant 2 for that one. So that's negative 1 to root 3 to 2. So sine of that is negative root 2 over 2. Cosine. Well, that one is negative 1/2. We have a plus. Cosine of that one, negative root 2 over 2. Sine of that is root 3 over 2. And then lastly, minus, and then sine of that nonsense. That's going to be this one again. So negative root 2 over 2. Alright, clean up. That's positive root 2 over 4. That's a negative root 6 over 4. And this one is a plus root 2 over 2. Oh, interesting. This looks different. Interesting. Okay. Well, oh, these ones are, hold on. This is denominator 4, denominator 4. This is denominator 2. Did I miss anything? No. Yeah, nothing's missed. Alright. So times 2 times 2. And let's get to combining. So everything is now denominator 4. So we have this one plus this one is going to be 3 root 2. And then we have a minus 6. Minus root 6 all over 4. Well, that's the answer. Interesting. So we do have a conflict between those two answers. So this one was fairly straightforward though, right? Let me think about it. Okay. So this is the original problem. We changed this one into that one. Top and bottom is times 3. Yep. And then we applied this template. It's going to be the 2 here is there. And then sine of. We have a minus first, so 23 minus 5 is 18. Oh, okay, okay. That's where things went wrong. So 23 minus 5 is 18, so that's all 18. Okay, so this first answer is wrong. Whoops. Let's just start over. So VOD watchers can just jump straight to the point. So we'll pretend that nothing has happened. Let's just start here. So this is the problem that we're doing. What we have to do is just get it close to the algorithm. Which one does it match up? It matches the last one because we have a sign of a minus sign of b. So we have the minus with that minus. So we're going to transform this one into this form, which since this is a minus, then it will be minus first and then plus second. Alright, let's get to it. So evaluating the situation, 2 from the algorithm, and the sign of a minus b. This one is base denominator 12, this is denominator 4, so we should match this one up. Top and bottom times 3. It's going to give us times 3 is 15, times 3 is 12. Alright. So now we can do 23. Oh, wait a minute. It was correct before. Interesting. Okay, it's too late. We've already embarked on the path. So we have 23 minus 15, which is not 18. It's actually 8. Yeah. Okay, that's weird. That is unexpected. And then, so that's done, and then this is done. But we need to divide by 2. Be very careful. So let's take this one, and that's a 24. Alright, and then times cosine of a plus b, so it's going to be this one plus this one, which is going to give us 38. I think the first effort was 28. So I think this is where the mistake was made the first time around, but let's double check. These portions are simplifiable, so we're going to get sine of pi over 3, which is perfect. Copy paste. And then this one looks unpleasant. Okay, this is the bad one. So it turns out we do need expansion after all. So top and bottom of divide by 2 is 19 pi over 12. Yeah, this is a prime number. So this one we need to expand it out. So you can see the shortcomings of this particular algorithm. Yeah. Alright, so that's kind of suboptimal. But that's okay. Let's just continue on. This is, again, we can evaluate this one. This one straight up is kind of nasty, so we're going to split that. So we need something 15 and 4. Yeah, 15 and 4. So 15 pi over 12 plus 4 pi over 12 gives us 19 pi over 12. And that's a good split. So we can do the expansion. This one is already nice. Copy paste. And here we go. We can just simplify that into 5 pi over 4. And this one simplifies into pi over 3. Cosine expansion, so cosine, cosine, sine, sine. Cosine of the first one times cosine of the second one. Don't keep the same sign, so it's minus. And then sine, sine. Because this is a minus and this is a multiplication, do we need to put the brackets? Sine of pi over 3. Alright. At least those two match up so we could save a little bit of trouble. This one is in quadrant 3. That one is in quadrant 1. So, copy paste 2. Sine of pi over 3 is root 3 over 2. Bracket time, we have this one, which is negative root 2 over 2. Times pi over 3. Cosine pi over 3, which is 1/2. We have a minus. Sine of that nonsense is negative root 2 over 2. Lastly, sine of pi over 3, which is root 3 over 2. Close the brackets. That one cancels with that one, leaving us with root 3. bracket evaluation. We're going to have plus, so that's going to be root 6 minus root 2 over 4. And then final cleanup. Oh, that looks kind of weird. That's okay. So we have root 18 minus root 6 all over 4. This one is simplifiable. We can yank out a, what is that, 9 times 2? Square root of 9 is 3. So 3 with a remainder of 2 in the radical. Whoops. And minus root 6 all over 4. Okay, so this is distinct from the first answer, so that's good. That means that this one's probably correct. Let's see if it matches. Does that match up? Yeah. Alright, so this answer is correct. Good to go. So again, I think for the first time, the first pass, this one was correct. It was correctly written for the first one, but then this one I maybe wrote like a 28. I think that's where it went wrong. Divide by 4. Yeah. I think that's where things went wrong the first time. First time around, I had written 28 when it's supposed to be 38. Yeah. But that's okay. These things do happen. Alright, so you know what? I think I'm just going to call it for today. Well, let me think about how many problems. 1, 2, 3, 4, 5, 6. You know what? No, let's finish it. Let's finish the situation. So that's going to be just evaluating the sum to product or product to sum situation with no variables. But now let's deal with variables in these situations. Yeah, let's just do it. I just want to finish as much as possible. So for the first problem, again, now we're incorporating the algebra into the situation. So we have sine of, here it comes, is going to be x minus 15. So that's the variable we're talking about, over 24. That looks kind of unpleasant. And then times cosine of x minus 3 all over 24 pi. I mean, the pi's on the side, not over. Alright. So we have this particular problem, and then that is equal to root 2 minus 1 over 4. Okay, so we're dealing with this particular situation. It is a product. So let's make sure we be as optimal as possible. So we're looking at the product algorithms. So it's going to be this one right here. Alright, so let's take this one and drag it along right next to it. And we'll just follow the formula as is. Are we missing anything? No. No awkward coefficients in the front. So this one matches this one perfectly. So we're going to apply this algorithm to this box. And we will equate it to this. So here we go. We have a 1/2 first from the algorithm. And then sine of a plus b just to make the colors nice. And thankfully this 24 here already matches that 24, so we can just sum the top portions. No weird fractions to, no divide by 2 to contend with, so we ain't gotta worry about that one right there. So add this one straight up to this one. So x plus x gives us 2x. Negative 15 plus negative 3 is negative 18. That's all over 24 with a pi on the side. So that's simplifiable. And then the second portion, we have sine of a minus b. Don't forget the plus. So do introduce the parentheticals. So plus sine of what? A minus b. So this one minus that one. X minus x is 0. And then negative 15 minus 3 is negative 12. Type pi all over 24. Okay, so we're done. Close the parenthetical. So we're done applying the algorithm to this one, thereby getting that. We need to copy paste the other side of the equation. So root 2 minus 1 over 4. Alright, so we might as well multiply both sides by 2. So times 2 and then times 2. This one is kind of a mess, but we can at least simplify this nonsense. Divide by 2, divide by 2, divide by 2. So we get sine of x minus 9 over 12 times pi. That one is 12 cancels with this one over 2, so we have a negative pi over 2, which is an interquadrant angle. Perfect. So that's going to be nice to evaluate. This one's unchanged. Alright, well, this one, we can work with that. This one, we cannot work with it at the moment, because this thing needs to be reduced by whatever this is. So, deal with this one first. That's interquadrant angle. It's negative, so it's a downwards pointing one. So that's the negative 1 opposite. So this whole thing evaluates to negative 1 over 1, which is just 1. Minus 1, I mean. Copy paste this. There we go, and then right there, copy paste. Plus 1 to both sides, so plus 1, and we need to combine these two. This is denominator 2, so we're going to do 2 over 2. So on the cleanup, we are going to get root 2, what's that, plus 1 over 2. This looks weird. That looks really weird. That does not look right. Hold on, let me think about this. Huh. Okay, thankfully I've already pre-done this problem elsewhere. So the problem lies right here. Huh. Let me do this again. So it's going to be this one. Don't tell me I copied the problem incorrectly. Oh, I copied the problem wrong. I'm going to have to start over. Unfortunately. This is actually a plus on the problem. Okay, I'm sorry. Let us begin again for the VOD watchers. And of course, the timestamp, I'll just stamp it up to the corrected point. Wonderful. Yeah, so this is supposed to be the plus. Everything else is correct. Okay. And now we begin. This is the problem. Right here, we've never seen it before. So this one is a sine of a thing times a cosine of a thing. So this is going to be product to sum or difference. So check the product situations. What do you know? It's already pre-marked. So we have a sine times a cosine thing. This is sine times a cosine. So we're going to apply this exact algorithm to this one because it matches. So I'm going to take this over and drag it right next to it. And for some reason, the A's and B's have already been marked. Alright. Who knows why. So this one matches that one exactly. So we could just apply the template. So there's a 1/2 in the front. Parenthetical, and then sine of A plus B. And this one already matches the denominator of this one. So we have x plus x, which is 2x. And then 15 plus negative 3, which is going to be positive 12. All over 24. Don't forget the pi on the side. So that's the first argument. We are done with that one. And then don't forget to put the second one. So plus also a sine function, but now it's going to be a minus b. So this one minus that one. So x minus x is 0. 15 minus minus 3 is 18. That's where things went wrong the first time around. Well, then all over 24. It went wrong because this one was copied wrong. Incorrectly. Alright, so we are done with the algorithm, so we can close the parenthetical, copy paste the right hand side. We might as well get rid of this, so multiply both sides by 2, so times 2, and then times 2, so partially cancels, just 2 on the bottom. Alright, this one, what can we do with this? This is actually no variable. Let's see what it simplifies. Divide by 6, divide by 6. So that's 3 pi over 4. And this one, we can evaluate it, which we should do, because then we could simplify this one with this one, which allows us to finally solve for just the sign. So evaluate this one first, copy paste this one. Well, we might as well simplify this as well. Everything is divisible by 2, so divide by 2, divide by 2, divide by 2. And this one we shall evaluate. It's in quadrant 2, so positive 1 to root 2 is the ratio, which means we can, yeah, that's correct. Root 2 over 2. Equals to what? Copy paste this one. It looks kind of a mess, honestly, but it's root 2 minus 1 over 2. We are attempting to solve for the variable which is right there. This one has no variable, so we're going to move it over to the other side. Subtracting root 2 over 2, subtracting root 2 over 2. And this is a root 2 minus a root 2, so those cancel out because the denominators work out. So we have a leftover of negative 1/2. Copy paste this one. I'm being very careful to put this on the side because this pi doesn't belong to just the 6. It belongs to the numerator. Alright, so this is a very familiar situation back when we're solving the trig functions, when you have something like sine of x is equal to negative 1/2, for example. So this one, we need to sketch out the situations. So where do we get a negative 1 over 2? That's in quadrant number 3 and quadrant number 4. So 2 scenarios to deal with. So the first one is going to be pi over 6, one space over, right? It's like 1 pi over 6 over half circle, so that's 7 pi over 6. So let me colorize this real quick. So from here to there is 7 pi over 6 to get to our reference triangle. And then of course we have this other triangle right here. So that's from neutral all the way to there, which is 1 pi over 6 short of full circle. So that's going to be 11 pi over 6. So that's what we're dealing with. And then we would force this one to be equal to this one. But because there aren't any domain restrictions, we do need to put plus 2 pi k, where k is an integer. And same is true for the other one, because we have infinite answers that are coterminal with this relevant reference triangle. So that one also put plus 2 pi k. And then if it was just x, then that would be our answer, and that would be our answer. But unfortunately, we have this kind of a mess right here. But that's okay. It's going to be the same overall idea. So we're going to force the inside, which is x plus 6 over 12 pi. And we're going to force that to be equal to this particular angle. But remember, there's infinite amount of those. So 7 pi over 6 plus all the coterminal angles, which is 2 pi k. So if we force this one to be any of those angles, then we will get a negative 1/2 ratio. And now just comes the manipulation. So multiply both sides by 12 to cancel, because we want to free the x. And then also divide by pi. So that cancels with that, and that cancels with that, leaving us with just x plus 6. And then this one to this one, so cancel with a 2. And then the pi's cancel, so 2 times 7 is 14. And then that one to that one. 12 times 2 is 24. The pi's cancel, keep the k. Alright, so x is thus equal to 8 plus 24k. So that should be all the answers, at least for the blue scenario. But now we have to deal with the purple scenario. So if we force the inside as a whole to be equal to this one, we can get negative 1/2 as well. Alright, so copy paste this. We're going to force that to be equal to the other scenario, which is 11 pi over 6. That's just one angle, that's just one answer. We need infinite, so we need to put plus 2 pi k. And that should capture all the scenarios. We just need to solve for individual x. So some manipulation is in order. Times pi over 12 again to clear those two. Getting us, getting us x plus 6. And then this one times this one. The pi's cancel, and then this one partially cancels, leaving us at 2 times 11, which is 22. And then this one times this one. It's going to give us 24k. And of course, solving for x is thus equal to 16 plus 24k. And thus, we have our two answers. We have that one and that one. So x is equal to two cases, x plus 24k, and 16 plus 24k. Where k is some sort of integer. And we're done with the problem. That was kind of a lot of, quite a bit of steps, right? Okay. And then moving on. Next on up we have cosine. Cosine of x plus 12 all over 12. Put a pi on the side. And then it's going to be times, that should already tell us where we're going. Cosine of x12 of pi. Alright, since this is a variable, it needs to be equated to something to solve for it. And it's equal to root 3 minus 2 over 4. So that's the known quantity. We just got to use an algorithm on this one. So we can't evaluate these ones individually because they both have variables in them. So we need to match the correct algorithm. So this is times cosine times cosine. So not these ones. Cosine times cosine is that one. It matches the form already, so we're just going to jump straight to the algorithm. 1/2 from the algorithm, put the parentheticals, and then cosine of a plus b. Thankfully, this one already matches the denominator of that one, so it's 2x plus 12 over 12. Don't forget the pi on the side. So first part is done, and then put the plus. Second part of algorithm, a minus b. So x minus x is 0, so 12 minus nothing is 12. And then 12, already put the pi. So here we are. I'll copy paste the right hand side. So root 3 minus 2 over 4. Here we go. Times 2. Oh, wait a minute. This is kind of careless. This is a times, this is a plus. So this parenthetical, close it right there. Okay. Here we are. Might as well multiply 2 to both sides. So times 2 clears that. And then times 2 partially clears that. And this one we can evaluate since 12 over 12 is 1. We're dealing with cosine of pi. That's an interquadrant angle. That's going to be this one pointing to the left. That's where the adjacent is same magnitude as the hypotenuse, but it's in the negative direction, so -1. Well, technically -1 over 1, but that one is just going to be -1. This one is simplifiable. We're going to get cosine of x plus 6 over 6 with a pi on the side. Copy paste this nonsense. Hopefully it's not too confusing. It's root 3 minus 2 over 2. Plus 1 to both sides. Plus 1. Plus 1. One equivalence at least. And we see that this one cancels with that one, leaving us with just root 3 over 2. Alright, so this becomes a classic situation that we're familiar with. It's going to be cosine of a thing is equal to root 3 over 2. Because we have no domain restrictions, this is going to be root 3. We could be in quadrant 1, like so. Or we can be in quadrant 4, like so. And just color code just for sake of keeping track. So we could be right here, which is 1 to 2 to root 3. So that pi over 6. That's only one angle. We need all the coterminal angles, so plus 2 pi k. And then, of course, second scenario is from here all the way to there. That's 1 pi over 6 short of full circle, so that's going to be 11 pi over 6. This feels familiar. So plus all the coterminal angles, plus 2 pi k. Alright, so whatever this inside part is, we're going to force it to be equal to scenario number 1, and then scenario, scenario number 2. But what is inside here? It's not just an x. It's an x plus 6 over 6 pi. So forcing this one equal to this one should capture all the scenarios that are in quadrant 1. So a little bit of clunky math. So times, I want to clear this, so it's going to be 6 over pi. So we're going to left with x plus 6. And that is equal to, oh, that's perfect, that's just a 1. And then this one to this one gives us plus 12k. We got a minus 6 minus 6. Whoops. Minus 5 plus 12k. I don't like this to be a negative, so I'm just going to, if k, we're going to take one of these, right? But bear in mind that they're whole numbers. So we're going to take one positive 12 and we're going to add it to this one because I just like the answer to be positive right here. It's not fully necessary. So we get 7 plus 12k. Because if k is -1, then 7 minus 12 takes us back to this -5. So that -5 is captured. But again, I just like this to be positive, so it's like this. So that's answer set number 1. Answer set number 2. Again, forcing the inside, which is this. So x plus 6 over 6, we have pi. And then we're going to force it to be equal to this one. What is that? So we have 11 pi over 6 plus 2 pi k. Yeah. Same tricks as before. Nothing new here. Times 6 over pi. Plus 1 to this one. The 6 is clear and the pi is clear. Leaving just 11. That gives us 12k. And then minus 6 is 5 plus 12k. So thus we have our two answers. So answer number 1, x is equal to what? We have the first set, which is going to be 7 plus 12k. And then second one, 5 plus 12k. And we should be good to go. That's it for second problem. And then let me cross that out. And then next problem up. What do we have? We have we got a cosine. X pi over 8, and then this is plus. That should tell us what direction this is going. And then cosine of negative pi over 12. That is equal to square root of 6 minus root 2 over 4. Let me make sure everything's copied correctly so I don't goof up. Yeah, okay, it looks correct. So make note of what's happening. We have a cosine thing and we have a cosine thing. What's happening between those two? It's a plus. So we're doing sum to something, right? Which of those is a match? It matches the top one. So we're going to follow that algorithm. And as a quick mention, we could actually go alt-strat. So this one right here, we don't have to force this algorithm onto the situation. We can transform this one using cosine expansion. We could change it into cosine of 3 pi over 12 minus 4 pi over 12. So this one expands, and then we can get actual discrete values, which we can move over to the other side, and then we just solve for the cosine. So that's a possible strat, but it might take longer. I'm not exactly sure. So we're just going to apply the algorithm just to see. You know, this is mainly to practice these annoying algorithms. So this one perfectly matches, perfectly matches that one. So as such, let's follow the algorithm. So copy the 2 from the algorithm times cosine. Unfortunately, this one is mismatched from that one, so we need common denominators. Let's just change this one into base 24. So top and bottom times 3. So we have 3x over 24 pi. On the pi on the side, I mean. And this one, top and bottom times 2. So negative 2 pi on the side over 24. Alright. Back to the algorithm, we have a plus b. So this is much easier to add. So 2 plus negative 2 is 1. 1 pi, right? All over 24, but just kidding, we have division by 2. So not 24, it's over 48. Oh, that's pretty bad. Is that what we want? Let me think about this for a moment. Yeah, how's that any better though? Let me think about this for a moment. Yeah, that seems really bad. Well, Because at that point, we still have to use expansion on this situation, right? That's really bad, unfortunately. I think I copied the problem correctly, right? We have 8. Yeah, that's copied correctly. Where do things go wrong? Okay, well. The unfortunate situation is just by looking at where these numbers are, this algorithm doesn't look like it's going to lead to anywhere nice. Maybe this problem was poorly written. Let me see my answer key real quick. Okay, I have no idea where the answer key for this one is, unfortunately. Okay, so you know what? I'm just going to change this. Listen, because this is going to lead to a very nasty situation, we're not going to force the algorithm after all. So the initial suspicion was to, well, that wasn't the initial suspicion. The initial suspicion was to actually use expansion on this one. But again, because this problem just looks so bad, just by looking at what we have right here, it's probably optimal just to go back to the beginning and just apply expansion. And then we'll simplify this and then solve for the cosine. Yeah. So unfortunately, this is not going to lead to a good exercise in forcing this algorithm in particular. But it is what it is. But let me take one quick pass just to make sure nothing got mistranslated along the way or mistranscribed. Let me think. So right off the bat, we see that this is a bad number. Okay. So I feel like the math is correct, yeah. So this one, top and bottom times 3 takes us to here. This one, top and bottom times 2 takes us to there. And that'll allow easy addition, but it adds to something very unpleasant. Yeah, that's just really bad. Let me check the other one. So if we had done the minus, do we also get a bad situation? Yeah, it's going to be 3 minus 2, which is 1. Oh, 3 minus minus, so that's going to be 5 pi over 24, but then 24 is divided by... Or did I get confused? No, I did not get confused. I'm just following... Yeah, following the algorithm directly. It's literally the A here on top, and then the B there, right there, and then you have to divide the result by 2. Which means that this is going to be a very unpleasant situation. That's unfortunate. Well, I guess we're skipping that problem for now. Maybe I'll come back to it if there's a better idea somewhere. Okay, so forget that, because the whole point is to use the algorithm, but if we have to use an alternative method, we'll save that for another time. Alright. Let's just skip on to the next problem. Next problem up, we have sine of x plus 9. It's all over. Hopefully didn't do this problem already, right? No. So sine of x plus 9 over 12 with a pi on the side, and then we have minus. So keep that in mind. Sine of what? We have x plus 1 over 12. Pi on the side. And all of that is equal to negative root 6 over 2. Alright. We do have a difference between these two trig functions. So we go to one of these three, it's the last one. And we'll just follow the algorithm. Hopefully things end up correctly this time. Yeah, it's a basically perfect match. So we have a with a negative right there. So therefore, this first one has to be a negative. And then the second one needs to be a positive. So copy paste, this 12 already matches this 12, so we're already good to go. So thus we have sine of, or rather, let's go in order. Copy paste 2 from the algorithm times sine of a plus a minus b over 2. So this one minus that one over 2. So x minus x gives us 0. 9 minus 1 gives us 8. Pi on the side. And then we have the 12, but we have this division by 2. So the 12 here becomes 24. And that looks good. Algorithm is looking good. Next part of algorithm is cosine. What do we have? A plus b. So this one plus this one. So x plus x is 2x. 9 plus 1 is 10. All over 12, but then the 12 one is modified by that division by 2, so it becomes 24 on the bottom. Don't forget the pi on the side. Let's go to copy paste this. That's simplifiable. Divide by 8, pi over 3. This one we can evaluate. Divide by 2. Divide by 2. Let's evaluate this one real quick. So, sine of pi over 3, that's going to be in quadrant 1, classic. Root 3 over 2. Alright. Sine of that, root 3 over 2. So this part simplifies into this. Copy paste the cosine portion, but simplify the inside. So you have cosine of x plus 5 over 12. Close parenthetical. Let's just leave that one as is, because we could simplify it with this one. Okay, so now both sides multiply by positive 2 over root 3. Because this one will cancel with that cancels with that. But to the right hand side, this one cancels with either of those two, and then this one partially cancels with this one. So we're going to be left with negative first, and then root 2 on the top, and then this 2 cancels with one of those. So we have 2 on the bottom. That's looking good. And copy paste this. Alright, so here we are at another one of these situations. I'm going to change this one to something I like a little better. So negative 1 over root 2. This is the cosine. So cosine of a thing, of an angle, is equal to negative 1 over root 2. So sketch the triangle scenario. We have scenario number 1, where we have a negative adjacent, and then root 2 for the hypotenuse. So one of those 45, 45, 90s is from here to there, quadrant 2. So that is 3 pi over 4. That's one angle. Getting all the angles is plus 2 pi k. And then second scenario with a negative adjacent, but the triangle is going downwards in quadrant 3. That's from here all the way there. So that's going to be 1 pi over 4 past half circle, which is 5 pi over 4. Get all the angles, plus 2 pi k. So we have our work cut out for us. So let's force this angle inside the argument to be equal to this one. And that will give us a ratio of that. So copy paste. Forcing the inside angle of x plus pi over 12, x plus 5 over 12 with a pi, and then equals this. And of course manipulations, we need to clear this 12, so times 12, clear the pi over pi. Just x plus 5 left. And then further distribution, that leaves us with a 3. 3 times 5 is 15. Sometimes this one is a 24. Pi's cancel, just k. Minus 5 minus 5. Final answer for situation number 1. 10 plus 24k. And that looks good. Second scenario, force the inside to be equal to this. So we have x plus 5 over 12 with the pi on the side is equal to that nastiness. So 3 pi over 4 and plus 2 pi k. Same manipulation, steal that work. So 12 over pi, leaving with just x plus 5. And then partial cancels 3. 3 times 3 is 9. Pi clears. 12 times 2 is 24. Don't forget the k. We have minus 5 minus 5, so therefore x is equal to 4 plus 24k. And we have our two groups of answers. So putting those together, we have x is equal to, we either have 10 plus 24k or 4 plus 24k. And I think that answer is good to go. Yes. Alright. I'm actually think I'm going to conclude it for this one. We're going to save the remainder problems. I think there's like 1, 2, 3. 3 problems left with the one dubious problem that was not optimal. So we'll come back to that one. So I think that'll be it for today. I probably won't stream tomorrow or the day after. So you have yourself a good one. Have a nice weekend. And I'll see you in the next.